This lesson will finish up the chapter on electrochemistry, and we're going to talk today about balancing redox reactions. Balancing redox reactions can be um, rather confusing, and so a process or a protocol has been developed to drastically simplify how these reactions can get balanced. And I'm going to summarize the process that we use, or the steps that we use to do that, and then we're going to demonstrate these steps with 2 or 3 examples. So the first step is to identify which species in the given chemical equations are oxidized and which are reduced. The second step is going to be to write the 2 half reactions. Number 3 is to balance the elements, everything except oxygen and hydrogen. So you balance all the other elements in the 2 separate half reactions. Number 4, you'll balance the oxygen by simply adding water molecules to counterbalance the oxygen that's already present in the system. Number 5, you're going to balance the hydrogen in the reactions by adding protons. Number 6, you'll balance charge. That is, you're going to use electrons by adding electrons. You're going to balance the charge in the molecules, the charges associated with the individual substituents on each species by adding electrons. We'll show you how to do that. Number 7 and number 8, we will need to, if we need to, we can multiply each half reaction separately so that each half reaction, when combined, will have the same number of electrons. And we will find in this balancing that will eliminate the electrons. Electrons cannot exist in chemical equations. Of course, electrons are not free in solution. They are always combined with molecules. And again, number 8, we add the balanced half reactions and we remove all species that appear on both sides, as we have done in many times in the past throughout the course. Again, electrons should always cancel. We will check to see that both the number of atoms and the number of electrons balance. And then the final step is to adjust the acidity based on the problem that is. Seems like every other horse enjoys bouncing along. That's a mnemonic that we can use to help us. In other words, step 1, separate the half reactions. Step 2, balance the elements other than hydrogen and oxygen. Step 3, balance the oxygens. Step 4, balance the hydrogens. Step 5, balance the electrons in each half reaction. The next step is to balance the total electrons so that the half reactions will combine and the electrons will disappear. And then the final step is to acidify or add base by adding hydrogen ions or hydroxide ions as necessary. All right, as an example, let's start out with a more simple one, and then we'll go more complex. But this example says balance the following redox reaction. Okay, and it has zinc and silver ions being reacted together. So let's do our following our steps. We will first separate the half reactions. So we have on this side, let's just start out with zinc 2+, and that's going to zinc. Okay, that's half reaction 1. We'll put a little 1 over here for half reaction 1, half reaction 2 on this side. What do we have here? So we've got silver, and let's write that the other way. It's going to silver plus. Okay. All right, so that's the first step. Now let's check to make sure that the elements are combined or are balanced. Are the elements other than protons or oxygens balanced. And this half reaction, that looks like that's the case. And this half reaction, that looks like that's the case as well. Now we'll balance oxygens, and of course there's no oxygens here, so that's an Na there. That's an Na there, no oxygens. Hydrogens, no hydrogens in this example either. Na, Na. Now let's balance the charges. So zinc has 2 plus. So what we're going to do here is we're going to have to add 2 electrons to this side, and silver has 1 plus over here. So let's add plus 1 electron on this side. Okay. Now the next thing we're going to need to do is we're going to need to balance the electrons. So we've got 2 here and 1 here. So we're going to have to multiply this guy by 2 to get the reactions correct. And so let's go ahead and do that. We're going to multiply that by 2, and I'm going to rewrite that reaction. So it's going to be 2 silver plus, 2 silver zeros, this elemental silver, is going to 2 silver pluses plus, and now we'll bring our electron into this because we've added an electron up here. And so that's plus 2 electrons. Okay. Now the final step is to add these 2 reactions together. So I'm going to go ahead and bring this one down. Zinc 2 plus 2 electrons, going to zinc in the 0 state. Now let's add these 2 reactions together. We've got zinc 2 plus 2 electrons. Now let's add the other side, the other half reaction, plus 2 silver, and then that goes to Ag plus 2 electrons. Okay. Now let's eliminate redundancies, and now we've already balanced our electrons, so that makes that step easy. Everything else appears, and I'm sorry I left out my zinc over here. Okay, I didn't bring that forward, but I did now. So now we have a complete balanced equation, and I'm going to just rewrite it here. Make ourselves a little clean space, and we're going to now rewrite that now balanced equation. So let's bring what we did up here. That's zinc 2 plus 2 Ag, and that's going to 2 Ag plus zinc, and that is a balanced redox reaction. Okay, let's clear those steps, and let's go to our next example. All right, we're going to do one now a little bit more complicated, but again, by breaking it down to seems like every other horse enjoys balancing along. Let's do that same thing here, and I think you're going to find just how simple these balance reactions really work. So first starting out with our 2 half reactions. So we have Mn O4 minus, and that's going to go to MnO2. And of course, I'm going to leave the solid out. That's a solid. And then we have silver, and that silver is going to silver plus. All right, so we've got our 2 half reactions, half reaction 1 and half reaction 2 over here. Now let's go through and check on the elements. We have to balance the elements other than oxygen and hydrogen. So we've got 1 there, 1 there, 1 here, and 1 here. So that checks. We're good there. Now let's balance the oxygens. And so we've got 4 oxygens there, and we've got 2 here. So in order to balance that, we're going to have to add 2 waters, are we not? 2 H2Os. Here, that's okay. Now let's go through and balance the protons. Protons. So now we have 4 protons over here. 2 times H2 is going to be 4. So let's add 4 protons right here. Okay. All right. So that's great. So far, so good. Now we're going to balance our electron. By the way, silver plus couple does not have any protons nor oxygens associated with that half reaction. All right, let's go ahead and balance our electrons now. All right, now how are we going to do that? Well, we got to look at the individual components, the species being oxidized and reduced in each half reaction. MnO4 minus, we're going to have to look at the charge on manganese, Mn. And the way we determine that is by first considering that oxygen is, when combined with most other elements, has a charge of -2. So 4 times -2, okay, is going to be -8. And let's just do a little simple math equation here. So we have a -1 charge there. So that means that we need a +7, right? So manganese has a +7. +7 -8 is going to give us the -1 charge that we need. Now MnO2 here, let's just kind of put that in parentheses, and I think that'll help us in just a minute. The manganese on this side, well, 2 oxygens times a -2 is going to give us what, a -4? So again, -4. And since that has no charge associated with it, manganese therefore has a charge of +4. All right, so we have a manganese with a +7 on this side, and we have a +4 here. So therefore, we're going to need 3 electrons on to be added to this side of the equation to balance out and give us the right charge, if you will, on that side of the equation. Okay. All right. So we're going to add 3 electrons there. Now let's go through and balance the electrons. All right. So we're going to balance the electrons by doing multiplying this equation here by 3. And that's going to give us 3Ag is going to, oh, I did miss a step. Let's go back to this step here. We're going to have Ag1 also has associated with a charge of +1. So we're going to need to add 1 electron here. We're going to need to add 1 electron there. Okay. All right. So now let's add, and now what I just started doing is going to make sense, because we're going to need to multiply the the silver half reaction by 3 in order to get 3 electrons, right? So 3 silver plus 3 silver going to 3 silver pluses plus 3 electrons will now balance the 3 electrons that we needed to add on this side, right? And again, we needed to add those 3 electrons to balance, to get the correct charge balance on permanganate, the MnO4. We had to have 3 electrons there, okay? Now let's bring all of this down, okay? Add everything together. MnO4 plus 4 hydrogens plus 3 electrons is going to MnO2 plus 2H2O. Okay. Now let's add the silver half reaction and the silver 3Ags add to this side of the equation. Okay, and then we just continue right along here, plus 3Ag pluses plus 3 electrons. Okay. All right, now we're gonna find ourselves a little real estate here. And we're going to rewrite everything so that we see it. All right, so did we get everything balanced? Well, let's first do this. We have 3 electrons here. We've moved 3 electrons there. Let's rewrite our equation. Clean it up a little bit. MnO4 minus plus 4 protons plus 3Ag is going to MnO2 plus 2H2O plus 3Ag pluses. All right, so let's just do a quick double check. We've got 4 protons over here. 2 times 2 is 4 protons over there. There's 4 oxygens here. 2 plus 2 equals 4 oxygens on the right side. We have 1 manganese on the left. We've got 1 manganese on the right. We've got 3 silver zeros here, and we have 3 silver ions there. And do our charge balances. We have minus 1 and 4 plus there. That equals plus 3 net on the left, and we have plus 3 net on the right. So I would say that we have indeed balanced this chemical equation. Okay? Let's clear that. And let's move to our next example. And the next example is going to be hydrogen peroxide reacting with tin. Okay, and okay, seems like every other horse enjoys bouncing along. Let's separate our half reactions. Okay, so let's have half reaction with hydrogen peroxide, O2, H2O2. We're just going to H2O on that side. And then we also have 10, 4 plus, going to 10, 2 plus. I'm sorry, let's do that the other way. Let's have 10, you can do it either way, it doesn't matter. 10, 2 plus, going to 10, 4 plus. Okay. All right, so the hydrogen peroxide here, let's go ahead and balance the elements. The hydrogen peroxide half reaction only has oxygen and hydrogen, so that balances. So far so good, at least. And then the 10, 2 to 10, 4, that's balanced. Those elements are balanced. Now let's balance the oxygen molecules. Okay, as we have for other here, we're going to balance the oxygens. Okay, well we see we have 2 here. We need 2 there. So what we're going to need to do here is out of water. Okay, how to get those oxygens correct. And let's see, we don't have any oxygens on the 10 couple. Now let's balance the protons associated with this the peroxide half reaction. And so we see we've got 2 protons here, and now we have 2 plus 2, 4 protons on this side. So what we're going to need to do is add 2 protons here. That little plus on top there, and that'll now add that'll equate the protons for both sides of that half reaction. Again, we don't have any protons associated with the 10 couple. Okay, now let's go through and balance the electrons. Now, in order to do that, we're going to first look at hydrogen peroxide. The 2 hydrogens hydrogen, of course, has a +1 charge in most cases. So that's going to be a +1 times 2. Times 2 equals, and I'm going to draw that out this way, that's going to be a +2. And that means that the O2 has a -2 charge, right? Which means that the oxygen on hydrogen peroxide has a -1 charge, right? Because you multiply that times 2 and you get your -2. All right. So in order to balance the charge, okay, and so now let's look at the charge on the water. Well, again, we have a +2 net, because each proton brings +1, and oxygen must have a -2 because we have only one of those, and water, the water molecule, of course, does not have a charge associated with it. So in order to balance the charge on the peroxide oxygen, since it only has a -1 charge, and we have 2 of those, we're going to need to add two electrons. Okay, 2 electrons here, because, and again, it's because we have two water molecules, right? On this side, remember, we have 2 of those guys. So in order to get our -2 to balance the -4 now, okay, in the water, associated with the water, so we have to add 2 electrons to the hydrogen peroxide side. Okay, we have to add 2 electrons to that guy to get the total number of electrons associated with hydrogen peroxide associated with the oxygen on hydrogen peroxide to equal -4, right? So each oxygen has -1. There's 2 of them, so we have to add 2 more to get a total of -4, and that -4 again will balance the -4 there. All right, so that balances the electrons. Now on the 10 side, we're going to find that we're going to need to add 2 electrons to the 10-4, are we not? 2 electrons to the 10-4. Let me clean that 10-4 up a little bit, make it look a little, that's a 4 plus. Yeah, we're going to need to add 2 electrons there. So, all right, so now let's pull our half reactions together in this step. So it's a hydrogen peroxide plus the 2 protons we've added, right? Plus 2 electrons. And that's going to now 2 water molecules, okay? All right. Now let's bring the 10 couple down, add everything together. 10-2 plus is going to 10-4 plus plus 2 electrons. Okay. Now, we need to do a quick check on the electrons. We see we have 2 electrons here. We have 2 electrons there. And therefore they balanced. So let's add everything together. So H2O2 plus 2 protons plus 2 electrons, and then bring in our plus 10 2 plus. And then that goes to, now let's bring the right side of the equations together. 2H2O plus 10 4 plus 2 electrons. Okay. All right, so I'm going to clean off a little real estate here so we can write this stuff back together in a cleaner way as we've going through the process of adding these two half reactions together. And so we'll let us combine and eliminate where we can. We have 2 electrons here, right? We got 2 electrons there. We can eliminate. And it looks like we have 110 on each side. And we have 4 protons on the, 2 plus 2 is 4 on the left, 4 on the right. And then the oxygens, we have 2 oxygens on the left, and 2 times water would give us 2 oxygens on the right. So let's rewrite this together. H2O2 plus 2 protons plus 10 plus, and that is going to 2H2O plus 4 plus, and that is it. Again, our 10s balance, our oxygens 2 and 2, protons 4, 2 plus 2 is 4, 2 times 2 is 4. This is a balanced redox reaction. Which is the oxidant and which is the reductant? Well, it looks like 10 is being 10(2) is being oxidized as we have it written to 10(4), and hydrogen peroxide or the oxygen, be more specific, the oxygen on hydrogen peroxide is actually being reduced from a -1 charge to a -2 charge. And that's why you have to look at the charges, the formal charges on atoms within some of the compounds in order to balance the charges with electrons, is because those charges are sometimes need to be balanced in order to take care of the fact that a reduction or an oxidation is occurring in those reductions or oxidations by our conventions are associated with individual atoms or elements within those within each of those compounds that's being affected. Okay, so that's that example. Just clear that one off and do one more example. And let's see which example that will be coming up. Okay, so we're going to balance the first equation highlighted here, and that equation is the reaction of SO3 minus 2 with copper hydroxide going to SO4 minus 2 plus copper 1 hydroxide. All right, so let's go ahead and begin to um, balance this redox equation using our mnemonic. Seems like every other horse enjoys bouncing along. All right, so let's separate, right? And we're going to separate, and I'm going to make a an observation here for everyone, and that is that we've got these two species on the left side of the equation. So we know they need to start out on the left side of our half reactions, right? And I'm going to go ahead and I'm going to put copper here, copper OH2. Okay, and then I'm just going to put its couple, the other half of the couple on this side, copper hydroxide. Okay, and then we're going to do the same thing with SO3 minus. Make sure SO3 minus is also on the left side of its respective half reaction equation. And we have SO4 or sulfate on the right side. Okay. So why am I bringing that point out? Well, the reason I'm bringing that point out is when we add these things back together at the end, we know that we're going to need to combine copper hydroxide, right? And SO3 minus 2. They have to be on the left side. We have to combine those to get to the sulfate and the copper 1 hydroxide on the right side of the equation. So we're starting out on the right foot. We got everything right for that ultimate step, that final step where we combine them back together. Okay. All right, so that's the first step, and the other thing too is I wrote copper hydroxide, copper 2 plus. I know that's a 2, right? Because the hydroxide it has 2 hydroxides on it, so I know that's being reduced. The copper 2 is going to copper 1 and copper because it's creating a copper 1 hydroxide on the reactant side of this equation. Okay, so I'm pretty sure that's going to be, or I am sure that's going to be reduced. That's going to take electrons. Okay. All right. So, and then similarly, we know this the SO3 minus, the sulfur, in fact, is being oxidized, is it not? Because it has the same charge. That should be a 2. By the way, I made a little error there. That's not a plus. That's a minus. You probably caught that. That's a 2 minus. So the charge is the same, but we're adding an oxygen. So undoubtedly the sulfur is being oxidized from left to right here, okay? So we got a reduction going on and we got an oxidation going on. All right, so let's go ahead and now balance the elements other than oxygen and hydrogen. We have one copper on the left, and we have one copper on the right. That balances. We have a sulfur on the left, and we have a sulfur on the right. So far, so good. That balances. Now, let's balance the oxygens. And remember how we do that? We have to add water. Now, we notice we have 2 oxygens here and only 1 oxygen here. So let's add plus water. Let's add an H2O there, okay? Make sure that's right. All right, now on the sulfur, the sulfite, the sulfate reaction, it looks like we're going to need to add a water on this side, right? Because we have 3 oxygens here. We've got 4 there. We're going to need another one, so we added water. Let's add the water. All right, now let's go through and balance our hydrogens. Okay, so we've got 2 hydrogens on the left of the copper couple, and we have 1, 2, 3 hydrogens on the right side of that, right? Because we added water, that's 2, plus the copper 1 hydroxide is going to give us 3. So we're going to need to add a proton right here, right? And let's do that. All right. Now let's similarly on the sulfite, the sulfate half reaction or couple. Let's see how we need to balance protons here. Oh, okay, so we've got 2. We had to add water. for the oxygen, and that gives us 2 hydrogens on the left. So we're going to have to add 2 hydrogens to the right. Okay, is that right? All right, very good. Now we're down to getting close to the end. We have to balance the electrons, balance the charges. All right, and I mentioned this right at the beginning of the step, but this copper has a +2 charge, right? The reason it does is because there's 2 hydroxides associated with it. This copper has a +1 charge, right? Because there is only 1 hydroxide associated with it. Let me get rid of my spurious mark there. Okay, so yeah, so in order to get the 2 to a +1, what do? Well, we just add 1 electron. That's all you got to do. Add 1 electron. All right, now let's get to the sulfur side of this equation. So oxygen, by convention, and as we know, normally has a -2 charge. There are some exceptions, but for many cases, it's a -2. With 3 of them, we have 3 times -2, and I'm going to go up here and say that's a -6. Okay. All right, now what would we have to add to -6 to get a -2? And I would hope you guys would agree with me that that's going to be a +4. So that sulfur has a +4. Now let's do the same thing on this side. The sulfate has 4 oxygens of a -2 charge. That's going to give us a -8, right? So in order to keep that net -2 charge on that ion, are we not going to have to assign an oxidation state of +6 to that sulfur side, or to that sulfur atom? All right, so we got a +4. Let me just circle these. Now we got a +4 sulfur and a +6 sulfur. So what I'm proposing is that we're going to need to add 2 electrons to that side of the equation in order to get our +6 down to +4, so that those charges will balance for us. All right, now we're getting close to the end. Let's go ahead and add everything together. So we're going to add the 2 half reactions together. We're going to add the right sides, and then we're going to add the left sides. We're putting it all together now. All right, so we got copper hydroxide, right, plus SO3 -2 plus, so we got that, we got that. Now we've got a proton here, plus H plus, and we've got an electron here, +1 electron. See a problem. All right, and that problem is this. We've got 1 electron on that side. So we're going to need to add an electron to that half reaction. And so what I'm going to do, and this is a really, we're real life working through this problem here, because I haven't worked through it before. And let me show you that in order to get this 1 electron to 2 electrons, we're going to have to multiply this half reaction by 2, and we're going to multiply the whole side by 2. So let's just let's take a bit of a step back here. Copper, and we're going to write down this just this half reaction. We're going to focus on it for right now. Copper hydroxide 2 plus proton plus an electron +1 electron, and that's going to copper hydroxide plus H2O. Okay, now we need to get that 1 electron too. Okay, so we're going to have to multiply, and instead, since my real estate is somewhat precious on my screen here, I'm just going to go back and I'm going to put a 2 here, a 2 here, clean this up a little bit. Two there, and remember that we got a plus. That plus is associated with the hydrogen, and now we've got 2 there, and two water molecules, okay, plus 2 water molecules. All right, now we've got that half reaction balanced, and I'm going to draw a little line here, and I'm going to draw a line across here, and we're going to bring down our sulfur half reaction, adding everything together. So SO3 minus 2 plus H2O, okay, is going to SO4, 2 minus, 2 minus, plus 2 H's, plus 2 electrons. Okay. All right. So now we have our electrons balanced such that when we add those two reactions together, we're going to be able to balance away the electrons, if you will. So let's go ahead and let's clean up our screen now. We've done all our pre-work, if you will, and we are in a position to combine and check these equations. All right, so let's do that. So we have 2 copper hydroxide, 2 plus 2 protons, plus 2 electrons, okay, plus, now let's bring in the sulfur, plus SO3 minus 2 plus H2O, and all that goes to 2 copper hydroxide plus 2 H2O plus sulfate, SO4 minus 2 plus 2 protons plus 2 electrons. All right. So let's see. Now let's go through. We're getting again close to the final step, and we're going to eliminate the electrons from there and there. Okay. We see also that we have 2 protons there, 2 protons there. We have on the left we have 1 water molecule, and on the right we have 2, do we not? So let's eliminate that one, and we'll make that one 1. Okay? So far so good. Now let's rewrite this. And see if we're right. Now we have 2 copper hydroxides plus SO3 minus 2 little bit nicer there. Okay. So I got that one, and it has that one. Okay. And then that goes to CuOH, okay, plus SO4 minus 2. All right, let's see if we're right. Let's go through and double check. We have 2 coppers here. We have on the left, we have 2 coppers on the right. So far, so good. Okay, we have a sulfur here, and we have a sulfur there. Sulfur on the left, sulfur on the right. That's good. How many oxygens do we have on the left? We have 3. 2 is 5. 5 oxygens, right? 5. 3 plus 2 here, because that's a dihydroxide. That's 5. 4 on the sulfate, and 2. I'm sorry. Let's see if we have 3. We have 4 here. 4 oxygens plus 3 equals 7. Okay. We have 2 oxygens plus 4 equals 6. We got a problem here, don't we? Let's see where we missed. 2 SO3. That's right. We've got I see my problem. We had a water molecule here that snuck in on us. Okay, so let's add that water molecule, because that guy needs to be added. So we're going to bring this down plus H2O. So now we've got 2 plus 4 is 6 plus 1 is, we have 7 O's, I believe I can convince you, on the right, and we have 2 times 2 is 4 plus 3 is 7 O's on the right. Okay, good. And then lastly, well, almost lastly, the protons. Let's check to make sure they check out. On the proton side of the equation, let's get rid of that. We're going to have 2 times 2 is 4, so 4H there. 2 plus 2 is 4H there. That part checks out. Now the last step here, almost the last step, is to make sure that the charges are indeed balanced. So we've gotten rid of our electrons, and the balances should be, or the charges on the left side must balance the charges on the right side. And so we have a -2 charge on this side. I believe I can convince you that that's a -2 there, since that's that comes from that molecule here. And correspondingly, we've got a -2 there. So this reaction is now completely balanced, and we have double checked that that balance is correct. Okay, so that is the way you solve a somewhat more involved equation, redox equation. But again, if you take care of the details, which of course you have to, and as I went through myself, I had to go back. But if you take care of all the details, you will find that this process that we have developed, this mnemonic and this tool for breaking it down into its component parts, works exceedingly well to solve what may look like a very, very challenging equation to solve. Okay.